Fibonacci of 3 is 2. So let's see whether we get the correct outcome. So we get the correct output as 2, right? So we can't stop by here because we have to check the boundary cases, which means we have to check the base case first. So now we have to check whether we get 0 as the answer if we ask to print Fibonacci of 0. So it displays the answer as 0. So let's check whether we get the correct answer for Fibonacci 1. So it displays the correct answer as 1. So the point that I want you guys to get from this coding is the concept of these recursive functions. So recursive functions, as I told you earlier, it means that we call this same function itself again on the smaller subproblems of this complex problem. So I have called this function Fibonacci in the smaller instances of this complex problem. So I have called this Fibonacci function, which I defined here, in the smaller instances of the same problem here, as you can see. Right? So this is what recursion is, or in other words, recursive function is. Then, so you guys might think, so recursion is also a kind of repetition. So I know you know about iteration. So iteration also means repetition. So you guys think, okay, so recursion is also doing the same thing, like recursion is also doing this repetition. And iteration is also doing repetition. So you might think that iteration is equals to recursion. But the main point that you have to keep in mind is iteration is not equals to recursion. So let's see how iteration differs from recursion. So earlier I showed you how we can code factorial using recursive functions. So I have defined the base case and I have defined the recursive case, and I have recursively called the function factorial on small instances of the complex problem. So now let's see how we can code factorial using iteration. So I know all of you know how to code this, so I'm not going to code it right now because all of you have coded in your programming class. So iteration, when using iteration, it involves for and while loops. So here I have used a for loop. So first I have defined that result is equals to 1 because if you ask to print the factorial of any given number, it starts with 1. So I can define result as 1. Right? You guys agree, right? Then I'm giving a range to this. So I'm giving for I in range to start from 1. I'm giving the starting point as 1 and the ending point as n plus 1 to know the reason for that. And the result, I'm asking to print the result as result into I. So I'm not gonna explain this code any further because you know this. So can you guys see any difference between these two functions? Because from both of these functions we can get the correct output. So do you guys see any difference? The main difference is in recursion we have maintained the repetition by calling the recursive function itself in its smaller subproblems. Here how did I maintain this repetition? By calling the function factorial again on the small instances of this subproblem. So this is how I maintain repetition in this code. But in iteration, I have maintained this repetition using a for loop. Right? Because I haven't called the function factorial again in another place of this function. You get what I'm saying? Right? And another difference is that recursive functions starts by dividing this complex problem into smaller subproblems. But on the other hand, iteration, it starts from the smaller instance, which is 1, and then it gradually builds up, right? So that is also another difference between iteration and recursive functions. So now my friend Tihara will be elaborating more on these differences between iteration and recursion.
So like Tarushi said, there are differences between recursion and iteration. So the main difference is that the recursive functions calls the smaller version of that function over and over again. However, iteration executes the same set of codes until we get the solution. And recursive algorithms start at a bigger problem and it goes dividing the problem until it gets the simplest problem. But iteration will start at a smaller instance and go to a bigger instance. Also, recursive functions can't be used to solve all the problems. Now earlier Tarushi asked a question if we can use recursion to divide all the problems. So the answer for that was no. So for problems like that, we can't use recursion. But iteration can be used to solve a lot of problems. Recursion is performed using functions, but iteration is performed as long as a condition is true. We use for loop or while loop for iteration. So until that while loop is true or until the for loop is true, we do the iterative process. Also, recursion may use a lot of memory space. We call it a call stack or a memory stack. But iteration will use a lesser amount of memory. And iterative codes, recursive codes are not that long, but iterative codes can take some length. Now, what are the benefits of recursion as compared to iteration? Recursion divides a bigger problem to smaller problems, which is easier to connect the problems and will also result in a more simpler and readable code. Also, recursive algorithms allow us to express a complex logic in a compact manner, which is easier to understand and maintain. Recursive solutions allow us to divide a bigger problem into sub-problems, following the divide and conquer approach. And each of these sub-problems are then solved individually, and these solutions are used to solve the bigger problem. Also, there are techniques which can be used to store and reuse these recursive algorithms which we have used before, which is us for calculations. And recursive functions are very efficient in handling tree-like structures, exploring each branch. Also, recursive backtracking can be used when we need to find solutions for a lot of problems with a lot of solutions. Now, what are the benefits of iteration as compared to recursion? Iteration can be more efficient in terms of memory usage or execution time as compared to their recursive solutions. Also, iteration gives us more control over the iterative process. It allows us to define loop variables, termination conditions, and step size, giving us a fine control over the iteration. Also, iteration is the default approach which most of the programming languages use. And most of the problems which involve linear operations and sequential processing is easier to solve using iteration than recursion. So just like everything has its pros and cons, recursion also has its drawbacks. So there can be excessive memory usage, or as I said, memory stack or call stack when we use recursion. Also, there is a potential for infinite recursion if the termination condition is not properly defined. And also, recursion can lead to a slower execution as compared to iteration for some problems. Now, Tarushi will explain how these recursive solutions are applied in the real world.
Thank you, Tihara. So now I'm going to explain the applications of recursive functions in real world. So the first application will be web scraping. So have you heard of this word web scraping before? Okay, so web scraping in simple terms, it means the automated extraction of data from websites. Right? So recursion in the context of web scraping refers to the technique in which it calls the recursive functions again and again on the small instances of this web scraping. So recursion mostly comes into action in web scraping when dealing with websites which has multiple or nested or hierarchical structures. So recursive functions allows this scraping tool or this scraping code to traverse through multiple layers of this website and to extract the desired data. And web scraping is very much useful when dealing with websites with complex structures such as online forums and e-commerce platforms with categories and subcategories. And also, it is very much essential to avoid the pitfalls that may encounter during the execution of this recursion, which are creation of infinite recursions and then excessive consumption of resources. So failure to do so will result in like crashing the program and excessive consumption of the resources. So we can avoid these pitfalls by properly defining the base case and by handling the depth of the recursion. So next comes cryptography. So some of you may have heard this word cryptography before. So cryptography in simple terms, it means the practice of securing information and communication in the presence of adversaries. So cryptography uses some techniques such as encrypting and decrypting of data to ensure its confidentiality, authenticity and integrity. So we can use recursive functions in some of the cases of cryptography. For example, in generation of cryptographic keys, we can use recursive functions. So if it involves complex mathematical calculations, so then we can use recursive functions to generate a more random and a more secure key. Right? And then also we can use recursive functions in cryptographic protocols. So in cryptographic protocols also, it has some substeps and subprotocols in it. So if we want to traverse through these multiple layers of these subprotocols, we can use recursive functions on each round for encrypting and decrypting of data. Then the next step will be next application will be artificial intelligence. So I'm pretty sure that all of you know what artificial intelligence is. But let me give a simple definition to this. So artificial intelligence is the ability of a computer or a machine to mimic human behavior. So recursive functions are widely used in this field of artificial intelligence. So for example, recursive functions can be used in tree and graph traversals, which enables the efficient exploration of hierarchical structures. And then, as Tihar explained earlier, we can use recursive functions in recursive backtracking also to find the most optimum or the most satisfactory solution from the available solution spaces. And then recursive functions are also used in neural networks which process structured data by capturing the hierarchical dependencies. And in addition to that, recursive functions can be used in the generation of integrate patterns and factors. So these are some of the cases or some of the applications where recursive functions are used. But there are many cases or many applications where recursive functions are used. Almost in every industry, recursive functions can be used. So with that, we come to the end of our presentation. So let me summarize what we discussed today. So first and foremost, I explained what is recursion, and then I explained how can we apply recursion and what are the main two components of recursion, which are base case and recursive case. And then we discussed the steps of recursive algorithms, steps of designing recursive algorithms. And then we saw how can we call recursive functions. And then we discussed the differences between iteration and recursion. And also we discussed how recursive backtracking works. And then we discussed we compared the recursion and iteration. And lastly, we discussed the applications of recursive functions. So before winding up our presentation, do you have any questions about this topic? So do you guys have any questions? Alright, so I think like we explained like this concept of recursive functions gotten into all of your heads. So I think that you all understood what recursive functions are. So with that, we are going to wind up our presentation. So thank you very much guys for listening to our presentation and for the support extended. So once again, thank you very much and good luck for your in-class assignment.